So block one, which is about the general physics. The last topic is pressure. We already discussed the main part. We'll first we discuss the definition of a pressure, which is a force acting on unit area. So how much force is acting on a unit area, that is called a pressure. If we want to increase the pressure, we should increase the force and we should reduce the surface area. Examples in which we are increasing the force by reducing area, like example a knife or a pin which is used, they are sharp so that the surface area is smaller and exert more pressure. Reducing a pressure by increasing the area, examples like squid having large area underneath the food, so it will exert less force, less pressure basically. Same is for tractors. Pressure exerted by the liquid depends on the depth, greater the pressure, and it also depends on density of the liquid. We can calculate the pressure exerted by the liquid multiplying the density of a liquid with gravity and depth. Then measuring the pressure, how we can measure the atmospheric pressure or device. We use mercury barometer, the simple concept of mercury barometer. Like it's an indirect way of calculating the air pressure. The air particles try to push this mercury, so it will rise in the tube. The moment mercury stop rising, it means the pressure of the mercury in the tube is same as the pressure of the air outside. So we can calculate the pressure exerted by the mercury by multiplying the density with gravity and depth, and that pressure of the mercury balances with the atmospheric pressure or air pressure. But atmospheric pressure is not constant, it varies. The normal atmospheric pressure at a sea level, it is 100,000 Pascal. A manometer is a device which is used to measure the gas pressure exerted by the gas. So it is comparing the pressure of atmosphere with the gas. If the level, the side where a gas supply is placed, if that level of a liquid is lower than the side where it is open, it means the gas pressure is more than the atmosphere. And if it is equal, both levels are same, it means the gas pressure is equal to atmosphere, and it can be other way around. This is what we have discussed till this point. Now, what are hydraulic system? Hydraulic system are based on the systems which use liquid to apply the pressure. We call them as hydraulic system, and it is based on the Pascal law or Pascal principle. What is a Pascal? You don't have to learn the statement for the Pascal law. That's why I did not include them in the slide. But what is a Pascal law? According to Pascal law, it states if pressure is applied on the liquid, it will transfer that pressure equally in all directions. That is called, because we know liquid apply pressure in all the direction, but if we apply the pressure on the liquid, that pressure is also transferred in all the direction, and we call that law as a Pascal law or Pascal principle. Again, you don't have to memorize this Pascal principle. So example, as you can see, this is a hydraulic lift. A hydraulic lift, we can have many applications of hydraulic principles. Hydraulic lift, hydraulic brakes, hydraulic jacks are also used. So example, we are applying a force of 15 Newton. There's a liquid inside, a hydraulic oil is there or normal oil is there, and we are applying a force of 15 Newton. And the surface area, the area of this piston, area of this side is 0.01. So how much pressure we applied on the liquid? So how we can calculate that pressure applied on the liquid? The formula to calculate the pressure on the liquid, pressure is force divided by area. So how much force we are applying? The force we are applying is 15. And what is the area on which we are applying the force? That is 0.01. So 0.01, so force is 15, area is 0.01. So 15 divided by 0.01, that is equals to 1500 Pascal. So if we are applying, according to Pascal principle, if we are applying 1500 Pascal on the liquid will apply same pressure in all the directions. So in all the direction, when we apply a pressure of 1500 Pascal on the liquid will apply same pressure in all the direction. So example, as you can see, the other side, the area of the other side is how much? It is 0.1. And we know, according to Pascal principle, if pressure is applied on the liquid will apply same pressure in all the direction. So how much is the pressure on this side? It will be 1500 Pascal. So we know the pressure and we have the area. So how much force is there? So we have the formula, pressure is force acting on unit area. So force is equals to pressure multiplied by area. So pressure is 1500 and area is 0.1. So 1500 multiplied by 0.1. As a result, we are getting 150 Newton force. So by simply applying a 15 Newton force, I can lift a heavy object. I can lift an object which is having a weight of 150 Newton. So this is called a force multiplier, that it multiplies the force. So using this hydraulic lift, we can apply a small force and we can lift the heavy objects. So what is the basic Pascal principle? It is stated that when pressure is applied on the liquid will apply same pressure equally in all the directions. So advantage of the Pascal principle, that we apply a small force. By applying a small force, we can multiply our force, or as a result, greater force is applied on other side. So I will repeat, look, according to Pascal principle, what pressure we applied on the liquid, the same pressure will be applied on the right hand side. That's a Pascal principle. It states the pressure applied on the liquid will transfer equally in all the directions. That is the Pascal principle. So we are applying a force of 15 Newton on the area of 0.01. So what pressure we applied? A force of 15 and area is 0.01. So we are applying the total pressure which we create, that is 1500 Pascal. So according to Pascal principle, a Pascal law, when a pressure is applied on the liquid will transfer same pressure in all the direction. I am considering only upward, but actually the liquid transferring same pressure in all the direction. But why I'm taking upward part? Because this side is movable, the piston is a movable part. So when we apply 1500 Pascal on the liquid will apply same 1000 Pascal other side. So what will be the output force? We have the formula, pressure is force on unit area. So pressure exerted by the liquid is 1500 and the area is 0.1. This 0.1 is divided, other side it will be multiplied. So how much force the liquid will apply as a result? The liquid will apply 150 Newton force. So it means we only applied 15 Newton, but as a result of a Pascal principle, the liquid can apply more force on the other side. So using this principle, we can lift heavy objects. Maybe you have seen, like on a garage, in the garage, the mechanics or tire repair shops, you will find why the pressure on the left hand side is same as the pressure on the right hand side. This is a law which is known as the Pascal law. According to Pascal law, when you what pressure you apply on the liquid will be same pressure on the other side. When something is a law, it means practically it is always coming at same. The experimental results are always same. So this is a Pascal law, a Pascal principle, which state when pressure is applied on the liquid, the same pressure liquid will apply on the other side or in all directions. Is it clear? Why I am not taking the forces? Because according to Pascal principle, the pressure is same, not the force. It's not talking about force. It always states the pressure exerted on the liquid. You can simply understand this term, the pressure exerted on the liquid is equals to the pressure exerted by the liquid. So it's about pressure. It's not about the force. It is always about the pressure. The forces can be different, the areas can be different, but the total pressure will remain same. Example, if we apply a force of 200 Newton on an area of 0.01, so how much pressure we apply on the liquid? Pressure is force divided by area. So force is 200 and area is 0.01. So 200 divided by 0.01. What is the pressure we applied? That is 20, that is 2000. Sorry, those two zeros are there. So it will be 20,000 Pascal. So how much pressure, now in this example, how much pressure we applied on the liquid? That is 20,000 Pascal. So as a result, how much pressure applied by the liquid will also apply the same pressure. That is because of the Pascal law or principle, the pressure applied on the liquid is same as the pressure exerted by the liquid. So liquid apply equal pressure what is applied on them. So we have the pressure and we have the area. So using this pressure and area, we can find the force applied on the other side. So according to Pascal principle, the pressure exerted on the liquid will always be same as pressure exerted by the liquid. The forces might be different. Example, maybe you have seen this hydraulic lift. I will show at a tire repair shop or a garage. Maybe you have seen this. It's very common. This is normally used if they want the wheel alignment or if they want to uh, check anything underneath the car or balancing the car. So normally they're using these hydraulic lifts. So figure 3.1 shows a hydraulic lift in a car repair workshop. So this is a hydraulic lift which is used in a car repair workshop. In the question, hydraulic fluid is there. Hydraulic fluid means any oil can be used here. The hydraulic fluid transmit the pressure caused by piston A equally to each of the four pistons. So what pressure we applied, not about the force, it is about the pressure. So what pressure we apply, the same pressure will be applied on each of these pistons. So if I apply 10 Pascal, what will be the pressure here? If we apply 10 Pascal, what will be the pressure on left hand side? So that will be 10 Pascal. What will be the pressure on the right hand side piston, the front right? That will be 10 Pascal. This will be 10 Pascal. This is also 10 Pascal. So as you can see, what is the advantage here? Like pressure is transmitted equally in all the direction. So we can multiply our force and we can increase our force by using the Pascal principle or hydraulic principle. and using this technique we can lift heavy objects. So in this example, a force of 1000 Newton is applied. So we apply a force of 1000 Newton. The pressure caused by piston A on the fluid. So how much pressure is there by the piston A on the fluid? So we have the formula, pressure is force divided by area. So we are applying a force, our force is 1000, and the area of this side, area of this piston is shown 0.01. So 1000 divided by 0.01. What will be the answer? So it will be 100,000 Pascal. So that is 100,000 Pascal. It means the pressure which we are applying on this is 100,000 Pascal. So how much pressure will be there in all the four pistons by the fluid? So it will be 100,000 Pascal here, 100,000 Pascal, 100,000 Pascal, and 100,000 Pascal. So all the pistons will receive the same pressure. So same 100,000 Pascal will be there in all the direction. So first part we have to calculate how much pressure we applied. The answer is 100,000 Pascal. The second part, we need the total upward force. The total upward force caused by the fluid. So how to get the total upward force? The pressure, as we already calculated, the pressure here is 100,000. Pressure is 100,000. Pressure is 100,000 Pascal. And here also pressure is 100,000 Pascal. So we can calculate the force, and area of each is 0.02. So we can calculate the force by one piston and multiply it by 4. So we'll get the total force. So we have the formula, pressure is force divided by area. We need the force applied because we need the total upward force. So each piston will apply the same force here, upward force, as the pressure is same and they all have the same area. So pressure is 100,000. Force we don't know, and area of each, area of one is 0.02. So this is 0.02. The 0.02 is divided, other side it will be multiplied. So 100,000 multiplied by 0.02, that will be equal to 2000 Newton. So force, the force exerted by each piston is 2000 Newton. So 2000 Newton from this piston, same way we'll calculate, we'll get the same answer, 2000 Newton from this piston. Same way we calculate 2000 Newton and 2000 Newton. The question was, what is the total upward force? So the total upward force, each piston is applying a force of 2000. So when we calculate the total upward, so it will be 2000 plus 2000 plus 2000 and plus 2000, or 2000 multiplied by 4. So total upward force will be 8000 newtons. So what is the advantage? Look, how much force we applied in the beginning. As you can see in the beginning of the question, we applied a force of only 1000. But as a result, because of hydraulic principle, our pressure is transferred equally, so that our force is multiplied, as there are 4 pistons. So we apply 1000, but as a result, the total upward force is 8000 Newton. So using a small force, we are able to lift a heavy object. So that is the main advantage. As we increase the number of the pistons, here in this example, we have only 4 pistons. So as we increase the number of the pistons, the upward force will also increase. Is it clear? The concept of Pascal principle? Any doubt in this part? So this is the Pascal principle, which states that what pressure we apply on the liquid, the same pressure will be transferred equally in all the directions. Example question, as you can see on your figure now. So in this question, the system shown is a diagram contain a liquid. The downward force is 4 Newton exerted on piston L. What will be the upward force? So how to do this? You cannot solve it directly. First, you have to calculate how much pressure is applied on the liquid. So how much pressure we are applying on the liquid? Our force, pressure is force divided by area. So force is 4 and area is 2. So 4 divided by 2, that's equal to 2 Newton per centimeter square. Why I did not write Pascal here? Because Newton per meter square is equivalent to Pascal. Newton per centimeter square is not Pascal. That's why you can write Newton per centimeter square. So the pressure which we are applying, is 2. So how much pressure the liquid will apply? On the other side, what will be the pressure exerted by the liquid? If we are applying 2 Newton per centimeter square, how much pressure will be applied by the liquid? Yeah, what will be the value? We are applying 2 Newton per centimeter. So according to the principle, what pressure we apply on the liquid will apply the same pressure. So the pressure exerted by the liquid will also be 2. So pressure is 2. Now to calculate the force, pressure is force over area. So pressure is 2, force we don't know, and area is 40. So this 40 is divided, other side it will be multiplied. So 2 multiplied by 40, the upward force will be 80 Newton. So we apply only a force of 4 Newton, but as a result, there is the force of 80 Newton on the other side. Yeah, the correct answer is 80 Newtons. Is it clear, this example? Hydraulic jacks, maybe you have seen, like example, in case if the car tire puncture, maybe you have seen these hydraulic jacks. How it works? It uses the same principle. Inside, this is completely filled with, this whole part is filled with liquid. So what we do, using a lever, we apply a force. Using a lever, we apply a force on a unit area, so we can create a pressure. The pressure what we applied, the same pressure is applied by the fluid upward, and as a result of this pressure, it will create an upward force. So using this hydraulic lift, using this hydraulic jack, we can lift the heavy objects, so we can lift this car so that its wheel can be repaired. Is it clear? It's the same principle, same idea. The pressure we apply, the same pressure applied other side. Because this is having a large area, so more force is there. At greater force, the object can be lifted up easily. This is what you see in the picture is a hydraulic jack. This is the support. This is called a support. That's afterwards, but this is a hydraulic jack. Any doubt in this part? Any question or a doubt related to this? Then hydraulic brakes. Maybe you have seen we are using a braking fluid, and normally most of the cars they have hydraulic brakes. What is the principle of the hydraulic brake? How it works? Like example, when the driver press the brake pedal, when he push this, as a result what happened? This is a pivot. So what force we applied? What force we applied on the brake? That force applied on the piston. Example, if we apply a 30 Newton force and this area is 1 meter square. So we are applying a force of 30 Newton on area 1 meter square. So what pressure we create on the liquid? That is force divided by area. So force is 30 and area is 1. Or I will take area as 2 meter square. So it will have a different pressure. So example, area is 2 meters square. So 30 divided by 2, we are creating a pressure of 15 Pascal. So according to Pascal principle, if we create a pressure of 15 Pascal on the liquid, how much pressure it will apply on the other side? It will apply equal. You can see these are the slave piston, means they can move. So there will be a 15 Pascal on the left hand side and 15 Pascal on the right hand side. So both sides it will apply same 15 Pascal left and right. So this is 15 Pascal right, 15 Pascal left. And if this is having area of say 4 meters square, this is the area of this side is 4 meters square and area of this side is also 4 meters square. So what is the force on the braking, what is the force on the brake shoes? So pressure is force divided by area. So force will be pressure multiplied by area. The pressure is 15 and the area is 4. So 15 multiplied by 4, that is equals to 60 Newton. So because of this fluid, there is a 60 Newton force on the towards the right hand side, and there will be a 60 Newton force towards the left hand side. So due to this 60 Newton force towards right and left, these brake shoe will come in contact with the wheel, and as they will come in contact with the wheel, due to the friction, the wheel will stop. So we only applied a force of 30 Newton, but as a result, our force is multiplied and we are able to stop the car which is moving at a high speed. Is it clear the working of hydraulic brakes? Any doubt in this part? Any question or a doubt in hydraulic brakes? So I'll repeat. Look what happened when we press the brake pedal. The blue arrow is representing the force, and the red arrow will represent the pressure. Okay. So we apply force on the paddle. Force is the push or the pull, and pressure is how much force is acting on a unit area. There's a difference between force. The force acting on a unit area is called pressure. So example, we applied a force of 30 Newton. So same force is there on this piston of 30 Newton. And this is example having an area of 2 meters square. So what is the pressure applied by us on the braking fluid, the master piston? That is, the force of 30 Newton is applied on 2 meters square. So we are basically applying 15 Pascal. So when we are applying a force of 15 Pascal, a pressure of 15 Pascal on the liquid will apply same pressure in all the direction. Because there are two pistons, one on the right, piston means the movable part, it can move. So liquid can push this towards right and it can push towards left as well. So this will be 15 Pascal towards right and it will be 15 Pascal towards left. If the area of this part is 4 meters square and this other part is also 4 meters square. So how much is a force? So force is pressure multiplied by area. Pressure is 15 and area is 4. So force will be 60 Newton. So there will be a force of 60 Newton which will push this brake shoe. And when it will push this brake shoe, the brake shoe will come in contact with a wheel, or braking drum will come in contact with a braking drum. So it will stop the car. Due to the friction between the brake shoes and this braking drum, when they will come in contact, the car will stop or the wheel will stop rotation. Is it clear? The working principle of hydraulic brakes on wheels. So it also uses the Pascal principle that what pressure is applied on the liquid, the same amount of pressure transferred equally in all the direction. But for example, if there was a air inside, there are air bubbles, and we are applying a pressure of 15 Pascal on the fluid, what will happen? The pressure applied on the wheel, it will be same or different? The other side, if for example we are applying a pressure of 15 Pascal and there is a air inside or there is air present with a liquid, so the pressure transferred here, it will be more than 15, less than 15, or equal to 15? If there are air bubbles present, what you can think about it? Yeah, it will be less than 15. Why it will be less than 15? Because the gases are compressible. Some of the pressure which we apply is used to compress these air molecules, compress the air bubbles, not molecules, air bubbles. That's why the pressure will not transfer equally, it will be a lower pressure. So if they ask what is the effect of having an air bubble inside this, the pressure will reduce. And what could be a reason for that? Because gases are compressible. So this was the last part from topic 1.8. We are done with block 1. Any question related to any topic in this 1.8? Any question or a doubt?